Hello, my name is Nathan Shaner, and I'm going to walk us through an iterated integrals calculus 3 problem that I have here in front of us. This problem in particular says find the mass of a triangular region with vertices 0, 0, 3, 0, 5, 0, with the density function of p of x and y equals x squared plus y squared. First, I'm going to show us the generalized formula for finding the area, or the mass in this scenario, right? So some area, let me actually write that as area, or let me actually write this as mass. Some mass in our case is going to end up being the integral or the double integral of some region R with respect to some function xy with respect to A. Now I'll explain this A part here in just a second. Let's talk about this region of vertices. I'm gonna express this as a triangle. It's gonna be easy. It's gonna be easy to see once I draw it out. And then I have all of our points of 0, 0. We have 3, 0, and then we have 0, 5. So now we have everything set out that the problem gives us. Now I can kind of walk us through this part. So instead of just having some generalized formula that's just the mass equals this, we can walk through it. So I'm going to start specifying some things. We're going to have some mass, and then I'm going to leave these integrals ready because we're going to have to put in some bounds to it. And those are going to be drawn from this triangle on of these vertices of our function, x squared plus y squared. And instead of writing this as dA, I'm going to write this as dy dx. And the reason I write this and the way that I like to personally think about it is instead of just this transformation happening, I like to think of it if you were to take some area, you have to describe it in 2 dimensions. In this case, we have an x, we have a y, and then if you were to multiply those, both of those together give you this shaded region, which is your area. That's why I'm just expressing dA as dy dx, right? So we're taking a little bit of y, a little bit of x, and that's what's making this actually happen. Now that I have it set out like this, really I'm going to break this up just as we walk through it. We're going to focus on the center part here. Is we're going to take an integral with respect to y. Now I have to find our limits. So the first part of our limit's pretty easy. It's just this bottom one. Both of them are going to start at 0, 0, right? So actually, I'll pen that in here real quick. Got 0, we have 0. And then this top end is where it gets tricky, especially with the y's, right? So I can't just write 0 to 5, because if I wrote 0 to 5 over our whole region, we're going to end up getting this whole dashed region as well, and then we're going to get this whole area. And that's not what we want. Instead, we have to express this as some, not function, some other expression. And the way that I'm going to do that is if I know if this is my y-axis, this is my x-axis, I could show this as 5 minus, because it's a negative slope, rise over run, so 5 over 3x. Great. And that's really my bound, right? So all this is saying is from 0 to whatever this is, as we walk along the x, this is going to show me this y value. So it's really going to plot out what this is in that direction. So this is going to be 5 minus 5 over 3x is the upper limit on that first y dy integral. And then for x, all we have to do is go from 0 to 3, because once we already had encapsulated that slope inside of the integral, then we could just go to the basics on the second one and just go from 0 to 3. So we have 0 to 3. Great. I'm going to show this with the color orange. Bow, bow. Awesome. So now it's just an integral problem. This part isn't the craziest part. So we're gonna go and we're gonna take the integral of some function first. So we're gonna go integral of x squared plus y squared. This is equal. Well, right. So this is with respect to dy. Let me throw that in there. Let me clean that up. With respect to dy equals x squared y, and then we have. I'm gonna write this as a 1/3 y cubed, And I like that better. Cool. So we're going to do this. Now we have to evaluate that from 0 to 5 minus 5 over 3x. Once you do all of that good algebra, that's going to end up simplifying after quite a few steps, it looks like here. Negative 260 x cubed minus 1530 x squared plus 3,375 x minus 3,375 again. Cool. And that is all over 81. Now, so now that's all plugged in, right? Cool. That is our evaluated integral. And the part that I like to note here is now that we're only left with x's inside of this whole term here. And then once we take the integral with respect to x now, we're going to get rid of all those x's. It's going to be a clear cut number. It's going to be pretty great. So now I'm going to show that. I'm going to make a little bit more space here on the right. Cool. Let's do this in orange because that's the bracket that we're working in, right? So just to re-express what we just did, this whole section here is now what we plug in for this green. So now I'm taking an integral from 0 to 3 of negative 260x cubed minus 1530 x squared plus 3375x minus 3375 all over 81. And this is equivalent to negative 5x 26x to the third minus 204x squared plus 675x minus 1350. And that's all over 162. So now, last step, I'm just going to color it for you guys. So you plug in, instead of all of these x's, we're going to go and we're going to plug in 3. And then you would formally plug in 0 for all the other ones. So you plug in the 3, you subtract off the 0. The 0 is going to end up evaluating the 0. You're not going to have to worry about that. That's great. So I'm just going to plug in the 3's. And once you plug them all in, you get a final answer of 42.5. Now that's your mass. That's it, really. This is what you get, right? So this is the volume under the curve of x squared plus y squared within the bounds that we already set by this region here. And that region, it is some triangle instead of some rectangle. And that's the reason why it's a triangle is because it has this 5 minus 5 over 3x, right? So it is a defined region. But yeah, that's it. That's your mass. It's 42.5. Cool. And that's it. All right. Thank you for listening.